Hi guys, good morning! Especially to the person who are watching this video. So, I would like to introduce myself. I am Jeffrey Libucan, taking the Bachelor of Secondary Education, major in Mathematics. For today's video, we would like to talk about the series. Our main topic is absolute convergence. But we would like to consider the other topic in order to distinguish the main topic. And these are conditionally converges and the diverges. So first, let's talk about the definition and condition of absolute converges, conditionally converges, and the diverges. In mathematics, an infinite series of number is said to be converged absolutely or to be absolutely convergent if the sum of the absolute values of the summands is finite. So if the sum of the absolute series is converges, then the sum of the original series is also converges. Therefore, it is absolute converges. So if the sum of the absolute converges is said to be converges, and the sum of the original series is said to be also a converges, obviously it is absolute converges or convergence. Now, let's proceed to the second one, the conditionally convergent. A series or integral is said to be convergent if it converges but does not converges absolutely. So, if the sum of the absolute series is said to be diverges, then the sum of the sum of the original series is said to be converges, then conditionally it is conditionally converges. So now let's proceed to the third one, the divergent. The divergent series is an infinite series that is not convergent, meaning that the infinite sequence of the partial sums of the series does not have a finite limit. So the condition so the condition if the sum of the absolute series is said to be diverges, and the sum of the original series is said to be diverges, obviously it is called the absolute divergence or the divergent. That's it. Now let's go ahead and do some example problem. Let's say we have a series of cosine n pi divided by n cubed. So what do we know about the cosine n pi? So cosine n pi, when we plug in 1, you're gonna have cosine n pi, and cosine n pi here is equal to -1 over 1. And when we plug in 2, you're gonna have cosine 2 pi, and cosine 2 pi is equal to 1 over 2 cubed. When we plug in 3, we're gonna have cosine 3 pi, and it is equal to -1 over 3 cubed, and so on and so forth. So now let's proceed to what is the absolute value of this series. So if we put an absolute value of this expression, notice that -1 here and +1 will gonna stay +1. The absolute value of cosine n pi If n is an integer, then it is equal to 1. So now, the absolute value of a sub n is equal to 1 over n cubed. And this is now the absolute value of the series, 1 over n cubed. And it will gonna have 1 over 1 cubed plus 1 over 2 cubed plus 1 over 3 cubed, and so on and so forth. So now, how do we know if this series is absolute convergent, or it is conditionally convergent, or uh, it is divergent? So notice that we have P series here, the n cube, or P series here, and P is equal to 3, and it is said that it is greater than 1, and therefore it is convergent. Convergent. So the absolute the absolute value of this series now is converges, and it is said that the original series is also absolute series, or it is converges. It is converges. Yes, that's it. So now let's proceed to the next example, and let's say that the series is goes like this. Series is equal to negative 1 raised to the power of n plus 1 all over the cube root of n. Cube root of n. So, what can you say about this particular series? Is it absolute convergence, or conditionally convergent, or divergent? So now let's now proceed to the process that what is the absolute value of this particular series. So n negative 1 plus negative 1 raised to the power of n plus 1. The absolute value of this is equal to a positive 1. Since this is absolute, all of this term will be equal to positive 1. So we can say that this particular series will be equal to 1 over cube root of n. Now, can you determine that this particular series is absolutely convergent, or conditionally convergent, or is it divergent? Anyway, we can rewrite this series to 1 over n raised to the power of 1/3. So notice that this particular series has a p series. So p here is equals to 1 over third, and p is less than or equal to 1. Therefore, this particular series is obviously divergence. So now this particular series is diverges. This is diverges. Now, since the absolute series is diverges, how about the original series? Is it convergence or is also diverges or conditionally converges? So now let's figure out what what is this. So if we plug in n to 1, so this will become 3 and 1. And when n is when n when n is 2, this will be negative 1 over cube root of 2. And n is 3, this will become positive 1. This will become positive 1 and cube root of 3. And it could be negative 1 cube root of 4 and so on and so forth. So as you can see, we have an alternating series here. So in order to determine this, we need to use the alternating series test. So first thing we need to do is we need to determine the a sub n, and the a sub n is not this term here is not included to a sub n. In order to determine the the function, so the next thing we need to do is we need to figure out this to the limit of function n is approaches to infinity. And this term is equal to 0. So it passes to the diverges test. So this is the next thing we're gonna do. So a sub n plus 1 is less than or equal to a sub n, and a sub n plus 1 is equal to 1 over cube root of n plus 1, less than or equal to 1 over cube root of n. And as you can see at this side, is that it has a large number of denominator, and that signifies as the whole that makes the whole fraction small and has a decreasing series. So therefore this no so therefore this particular series here is convergent based on the alternating series test. So now let's summarize what we have now. So at the first, the the absolute series is said to be divergent, and the original series is said to be the convergent. Therefore, this thing here is called as conditionally convergent. So that's it. So now let's proceed to the third example. Let's say that we have the series of negative 1 raised to the power of n times the n raised to the power of 3 all over n raised to the power of 3 plus 5. So first, let's rewrite the expression to the absolute value of the series. Now, the absolute value of negative 1 raised to the power of n is equals to 1. So we can say that the the absolute value of the series now is equal to n raised to the power of 3 or n cubed over n cubed plus 5. Now, let's say if the particular series, the particular absolute series is absolute converges, or is it conditionally converges or a divergence. So first, let's start with a divergence test. Now let's take a limit that n is approaches to infinity, and these are the series now. Now we will gonna multiply the the up and the bottom to 1 over n cubed. Same thing at the bottom, 1 over n. And now we're gonna have the result of 1 over 1 plus 5 over n cubed. And when n goes to infinity, so this will be equal to 1 over, this will be negative 1 raised to the power of n times the n cubed all over the n raised to the power of 3 plus 5. So if we plug in 1 to the n here, if we plug in 1 to this, the result will be negative 1, positive 1, and negative 1, and positive 1. So notice that it is again uh, alternating series. So therefore, this original series is, we can say that this is does not exist. So since that the limit of n goes to infinity for a sub n is not equal to 0. So this means that this this particular series is not only filled in the divergence test, but it also fills in the alternating test. So therefore, we can say that the original series is diverges. So To sum up, what we come up with this particular series or problem. So in the summation of the absolute value of a particular series, it says that the absolute value is equals to the. It says that it is divergent, diverges this, diverges, and the original series, which is a sub n, is also equal to diverges. Therefore, this particular series is the diverges, diverges, absolutely diverges. So that's it for today. Thank you for listening. I hope you learned a lot and see you next lesson.